Hello everyone, welcome to the tutorial on the C programming language. This is our 15th lecture in which we will discuss about the character set and the C token. So these are the outline of our today's lecture. First we will discuss about the character set that will supported by a C programming language. Then we will discuss about the C tokens like a keyword, identifier and different type of the constants in a C. So before starting a character set, let's have a quick revision about the programming language. As we know that a programming language is designed to help us process certain kind of a data consisting of a numbers, characters and a string, and to provide a useful output known as a information. So the task of processing data is accomplished by executing a sequence of the instruction that is known as a program. These instructions are formed using a certain symbols and words according to some rigid rule that is known as the syntax rule. So compiler collect the characters of a program into a tokens, and then tokens make up the basic vocabulary of a computer language. The compiler then check the tokens to see if they can be formed into a legal string according to a syntax or not. So these are the overview of the any programming language. So next, let's start with the character set. The character set is a fundamental raw material of any programming language that are used to represent the information. Like a natural language, computer language will also have a well-defined character set which is useful to build a program. The character that can be used to form a words, numbers and expressions depends upon the computer on which a program is run. However, a subset of the character is available that can be used on a most personal, micro, mini and mainframe computers. So, in the C programming language, the characters are grouped into following categories. First one is the letters, digit, special character and white space. Let's discuss each and every one in a detail. Starting with the letters. In a C, there are alphabetic letters like capital A to Z and small a to Z. Then second one, digits, 0 to 9 digits. Third one, special characters like plus, minus, multiplication, divisions, open round bracket, close round bracket, open curly bracket, close curly bracket, hash, question marks, etc. Then white space. There are a special white space character set available in a C. /B for a blank space, /T for a horizontal tab, /V for a vertical tab, /R for a carriage return, and /F for a form feed, /N for a new line. We will discuss this in detail. Let's have a difference between carriage return and form feed. Suppose you are writing a printf hello students /r hi. That means we are using a carriage return. So what will happen? It will go to a starting and feed whatever you have written after /r. Here he will be replaced by hi. See, you can see the output over here. While in a form feed, it will go to a new line and give a space that is given in a previous letters. Suppose here we are writing hello students /FHI. So it will go to, after this it will go to a new line and it will feed the character number of the spaces that is given before a /F, and then it will print whatever written after /F. So next we will discuss about the C tokens. In a passage of a text, individual words and the punctuations marks as a called as a token. Similarly, in a C program, the smallest individual units are known as a C token. In a C language, programs are written using these tokens and the syntax of the language. C has a 6 type of the tokens that is so over here like a keyword, identifier, constant, string, special symbols and operators. Later we will discuss each and every one by one. First we will discuss about the keyword. Keywords are the C token that have a strict meaning. They are explicitly reserved and cannot be redefined. All the keywords have a fixed meaning and this meaning cannot be changed by a user. Keyword serves as a basic building blocks or a program statement. These are the various keywords that is used in a C programming language like a break, case, character, const, continue, default, do, while, else, enum, sort, shine, void, while, etc. Each and every one we will discuss in our next tutorial. Next, we will discuss about the identifier. Identifier refers to the name of a variable, functions, and array. These are user-defined names and consist of a sequence of the letters, digit with letter as a first character. Both uppercase and lowercase can be permitted, but most of the identifier we will use the lowercase. The underscore character is also permitted in an identifier. It's usually used to link between two words in a long identifier. Here there are some rules to define an identifier. First character must be an alphabet or underscore. It's only contain a letter, digit and underscore. Only 31st characters are significant, cannot be used keyword. Reserved keywords cannot be used as identifier and must not contain any white space. Now let's discuss about the constant. A constant is a value or an identifier whose value cannot be altered during a program. A constant refers to a fixed value that the program may not alter during its execution. These fixed values are also known as literals. Constants are treated just like a regular variable except that their value cannot be modified after their definition. So these are a different type of the constant, like a numeric constant and the character constant. Numeric constant have a two type as an integer or real type constant, where the character constant will be divided as a single character constant as well as a string constant. So next, let's discuss about the integer constant. An integer constant is referred to as a sequence of the digit. There are three types of the integer constant: decimal, octal and hexadecimal. So decimal integer is the collection of the digit from 0 to 9 with the optional sign minus and plus, like 123 minus 321. This will indicate the negative number. Next one is a octal integer, is the collection of the digit from set 0 to 7 with leading 0, like a 037 0. If any number start with the 0, that means it is a octal number. And next is a hexadecimal integer, a sequence of the digit preceded by a 0x or 0 capital X is considered as a hexadecimal number. They may also include a alphabet A to F or small letter A to F. The letter A to F represent a number from 10 to 15, like a 0x2, 0x95, etc. So this is all about the integer constant. The largest integer value that can be stored is a machine dependent. For a 16-bit machines, you can store a largest 32,767 number. It is also possible to store a large integer constant on this machine by appending a qualifier such as a capital U, small u or capital UL to a constant, like a 5679U, that is an unsigned integer. UL stand for unsigned long integer and L stand for the long integer. So this is all about the integer constant. Now let's discuss about the real constant, that is also known as the floating point constant. As we know that integer numbers are not sufficient to represent quantities that vary continuously, such as a distance, height, temperature, price and so on. These quantities are represented by a number containing a fractional part, like a 17.543. Such numbers are known as a real number or a floating point constant. There are two types of the floating point constant. One is the single precision and another is the double precision. Let's start with the single precision constant. Single precision floating point standard represent required 32-bit word, which may be represented as a number from 0 to 31 from left to right. So the first bit is used for a sign bit, that is S. The next 8 bits are exponent bit, that is represented by a E. And the last 23 bits are known as the fraction part, that is represented by a F. So second type is a double precision. The IEEE double precision floating point standard represent require a 64-bit word, which may be represented as a number from 0 to 63 from left to right. The first bit is reserved for a sign bit, then next 11 bits is represent exponent part, that is E, and final 52 bits represent the fractional part by a F. So this is a representation of the single and double precision floating point number. So floating point constants are normally represented as a double precision quantities. The sufficient F or capital F is used to force a single precision and L and capital L to extend a double precision floating point number. So next, a real number may also be expressed in an exponential form. For example, the value 215.65 may be written as a 2.1565 E2 in exponential notation, where E2 means you have to multiply this number with 10 raised to 2. The general form is mantissa E exponential, where the mantissa is either a real number expressed in a decimal or an integer. The exponent is an integer number with an optional plus and minus sign. The latter is separated. Mantissa and exponent can be written in either lowercase and the uppercase. Next, we will discuss about the single character constant. A single character constant contains a single character enclosed within the pair of the single quotes, like a single quote 5x. The character constant have an integer value known as the ASCII, American Standard Code for Information Interchange. Suppose you are writing a character with the integer, that will give you an integer value of a, that is the 97. If you are printing a 97 as a character, it will give a character value of 97, that is a. So next is a string constant. A string constant is a sequence of the character enclosed in a double quotes. The character may be a letter, number, special characters and a blank space. Example, double quote hello 199, hello everyone, hello space student, etc. So these are the different backslash character constants, slash n slash r slash v slash o slash b, etc. So within this lecture we have discussed about the C character set, tokens, identifier, keywords and character constant and different type of the constant. Thank you.